The most common searching methods are linear search and binary search. LOC is equal to -1. I will initialize LOC value is equal to -1. It does not exist. When the elements of the array in sorted order, already it's in sorted order, the best method of searching is binary search. Binary search means when the elements are in sorted order, how to find the particular location or position of the array. Welcome back to my session. I am Shweta, Computer Science Faculty, Vidhyaashram College, Mysuru. In my last session, I have discussed about basic operations on one-dimensional array. We have discussed traversing and insertion and deletion operation, right? Traversing means the process of visit each element of the array exactly once. It will visit each element of the array exactly once, and I have discussed an algorithm with an example, and also I have discussed deletion operation and insertion operation. So what do you mean by insertion operation? Insertion means inserting a new element into the array. Inserting a new element into the array, we have to use some procedures. And what do you mean by deletion? Deletion means removing an element from the array. Removing an element from the array is called as deletion operation. So today I am going to discuss about searching an element in an array. Searching means searching an element. Searching refers to finding the location of the element in a linear array. We have to find the particular location of an element in an array. So searching means finding the location of an element. And there are different algorithms, but the most common methods are linear search and binary search. And in searching we have different methods. The most common searching methods are linear search and binary search. Very important question, linear search and binary search. So first I will explain what is linear search. This is the simplest searching method in which the element is to be searched is compared with each element of the array by one from the beginning to end of the array. We have to search the element from beginning to end of the array. Searching means searching an element in an array from beginning to end of the array. We have to find the each location of the array. And searching is one after the other. It is also called as sequential search. In linear search, we have to search the element one after the other. That's what we can call it is a sequential search. Linear search is also called as sequential search. Why it is sequential search? So we can search each and every element one after the other, one after the other. So we can call it this is a sequential search. Let us understand the algorithm for linear search. Here A is an array with n elements and element is being searched in the array. We are going to search one element in the array. Example 1, 2, 3, 4, 5. Here I am going to search the position of the element 3. What is the position of the each element? A of 0, A of 1, A of 2, A of 3 and A of 4. Here I want to search the location of this element 3. Clear? Here I wanted to search the location of this element 3. How to search the element of the location 3? So what is the first step? LOC is equal to -1. We'll initialize LOC is equal to -1. But we don't know from the beginning till end of the array where the element is located. So I will assume location is equal to -1. This LOC is equal to -1. It does not exist because all the index value should be positive. All the index value should be positive. So simply I will assume LOC is equal to -1. And for p is equal to 0 to n minus 1 do. Here we are using for loop for p. P means it is the location of the element, and step 2 is for p is equal to 0 to n minus 2. Here I am using the for loop. For P means it is the position of the element, and 0 to n minus 1. This is lower bound and this is upper bound. So we have to check the position of the array from 0 to n minus 1. 0 to n minus 1 from lower bound to upper bound. So P is equal to 0 to n minus 1. Here I am using for loop. P is equal to 0 to n minus 1. And if element is equal to A of P, element is equal to A of P, then LOC is equal to position. If your element is matches, then we can call LOC is equal to P. Then go to step 3, then end of for loop. I will show you with an example. Consider the following elements stored in an array and we are searching for the element 35. So item is equal to 35. Item is equal to 35 and the given array is 10, 20, 30, 40, 50, 60. 10, 20, 30, 35, 40, 45, 50. This is the name of the array. We have 9 elements. So index starts from A of 0, A of 1, A of 2, A of 3, A of 4, A of 5, A of 6, A of 7 and A of 8. So index starts from 0 to 8. We have 9 elements. So here the item we are going to search is 35. We have to search an item called 35 and location of this item also we have to search. How to search the location of this element 35? Here we have to use the for loop called for P is equal to 0 to n minus 1 and element is equal to A of P. For P is equal to 0 to n minus 1 if element is equal to A of P. So here P is equal to 0 to n minus means 0 to 8. We have 0 to 8 and we have to search an element if A of 0 is equal to element. Here we are going to search from the beginning A of 0. A of 0 means it is 10. 10 is equal to element is, we are going to search an element called 30. Is this matches? No. 10 is not equal to 35. Then again for loop will continue. For P is equal to 0 to 8. So next element we are going to search A of 1. We are going to search the next element called A of 1. So what is A of 1? Element is 20. So 20 is equal to 35. 20 is equal to 35. Is it correct? No, it's not matches. So again we'll go for next loop and X A of 2. The next location is A of 2, that is equal to LE. So A of 2 means this 30 equals 35. Is it matches? No, it's not matches. And again we'll go for loop and if A of 3 is equal to LE, A of 3 means it is 35. 35 is equal to 35. Is it matches? Yes, the condition is true. So we got the position of the element, that is A of 3. So condition is true means it can print the elements. This is called as searching an element from the array. Here we are going to search an element called 35. The location of this 35 means that is A of 3. So we have to use this for loop for finding the element of the array, and we will get location is equal to P and go to step 3. And if your element has not searched, if your element has searched means it can print the elements. So searching is successful. If your element has not searched, so if LOC is greater than or equal to 0. If your value is greater than or equal to 0, then print element found in location, and else not found. Print element as not found and exit. So, if your element has search means it prints the element, so search is successful. If your element has not search means if a location is greater than or equal to 0, if your item is greater than or equal to 0 means then it will found in location, and print element as not found. Element as not found, then exit. This is your linear search algorithm. So, first is LOC. I will assume LOC is equal to -1. Just for reference, LOC is equal to -1. I will initialize LOC value is equal to -1. It does not exist. And again I will go for loop. For p is equal to 0 to n minus 1 means from index 0 to n minus 1. It will check the conditions from each and every steps from beginning to the end. And if your location is search means LOC is equal to p. This is called linear search. This is one example for linear search. In this array, we are going to search an element called 35, that is your item is equal to 35. So, we have to find the position of this item, that is A of 2. Already we found the position of the element called A of 3. This is called linear search. You can give any examples for linear search. First, you have to take the number of elements with index values, and you have to find one particular item in a given array. You can use this for loop and you can find the particular item in a given array. This is called linear search. So, searching means searching an element. This is your linear search. Next, we'll understand the binary search. So, what do you mean by binary search? When the elements of the array in sorted order, already it's in sorted order, the best method of searching is binary search. In binary search, if the elements are in sorted order, we can find the particular order of the element. This method compares the element to be searched with the middle element of the array. Using the middle element of the array, we can search the particular element in a sorted order. So, you can use middle element of the array for searching a particular item. If the comparison search either at the right off of the array, or the left off of the array. I will show you with an example. And in binary search, we can assume position of first array is called as BEG, beginning, and last is called as end of the array, and the middle element is called as A of mid. This is very important. The position of first element is called as BEG, that is beginning, and last element is called as end, and the middle element is called as A of midpoint, and can be obtained by find the middle location mid by using the formula called mid is equal to beginning plus end divided by 2. Mid is equal to B plus E, beginning plus end divided by 2. So, M is equal to B plus E divided by 2. Using the midpoint value, we can find the particular item in a given array. First, I will show you the example problem, then we will understand the algorithm. Apply the binary search for the following sequence of number 10, 20, 30, 35, 40, 45, 50, 55 and 60. Search for item 30. Here we are going to search an item called 35. Here the elements are already in sorted order, that is in ascending order, right? So, here we have to search an element called 35. This is one example. We have number of elements called 10, 20, 30, 10, 20, 30, 35, 40, 45, 50, 55 and 60. Here we have 9 elements, A of 0, A of 1, A of 2, A of 3, 4, 5, 6, 7, 8. A of 0 to 2, 3, 4, 5, 6, 7, 8. So this is the name of the array. Here we have number of elements. Here we have to find the item called 35. Here the item called 35, we have to find the position of the element 35. So in first iteration, what will happen in first iteration? B is less than or equal to E. So what is B here? B means beginning element and E means end of the element. So B is 0 less than or equal to 8. This condition is true? Yes, this condition is true. 0 is less than or equal to 8 only. Then find the midpoint value. B means 0 plus 8 divided by 2. It is 4. Mid value is 4. Element is equal to A of M. Element is equal to A of M means it is 4. Here we got A of 4. Here we have to compare with the elements. Element is 35. The item element is 35 less than A of M. A of 4 means, what is A of 4? It is 40. So this condition is true. We can reset the value. E is equal to M minus 1. So what is M? M means 4. 4 minus 1, you will get 3. So this is your end value. 3 is equal to 4 minus 1. So it will remain same. So location, I will assume it is minus 1. In the second iteration, what will happen? B is same and E means it is 3. Here we got the value E is equal to 3. So find the mid value. 0 plus 3 by 2. So 0 plus 3 by 2. Here in program we are using M is equal to int of B plus E by 2. Here we are using the integer value. Sometimes you will get quotient value, so you need to consider the first value. Example 1.56 you will get, so you need to consider only the value 1. Example 3.12, you have to assume the value, integer value is 3 only. So here 0 plus 3 by 2, 3 by 2 means it is 1.3. So I will assume it is only 1. The first integer value I will assume. So M is equal to LE is equal to A of 1. So here element is equal to A of 1. A of 1 means what? It is 20. So we have to compare the values. 35 is greater than 20. So we have to reset the value. This will remain same. B is equal to M plus 1. So 1 plus 1 you will get 2. So here B is 2. This will remain same. The third iteration, B value is 2 less than or equal to E value remains same, that is 3. Find the midpoint. 2 plus 3 by 2, it is 5 by 2. I will take 2. 2 is an integer value, first value I will assume. So here LE is equal to A of 2. A of 2 means what? It is 30. 35 is greater than 30. So you have to reset this again. M means it is 2. 2 plus 1 will get B value is 3. This will remain same. And in the fourth iteration, so what is the B value? B value is 3 less than or equal to E value remains same, that is 3 only. So find the mid value. 3 plus 3 by 2 you will get 6 by 2, that is 3. So LE is equal to A of 3. So here LE is equal to A of 3. So what is A of 3? A of 3 means it is 35. So we got the searching element. So 35 is equal to 35. So location is equal to 3. In the third location we have the item called 35. This is called binary search. So in each and every step we have to find the value of B, that is beginning value, and end value and midpoint value. Mid is equal to B plus E by 2. Use this formula, easily you can find the position of the each and every element. So E is equal, you have to reset the value. If your element is less than A of mid, you can use this reset value. If your element is greater than A of M, you can use this B is equal to M plus 1 and you can find the location of the given array. So item is equal to 35. In location 3, we have an item called 35. This is called binary search. This is one example for binary search. Using this example, I will explain the algorithm. So set b is equal to 0. B means beginning value, that is 0 to end value is n minus 1. So 0 to n minus 1. In example problem, I have considered it is 0 to 8. Location I have said it is minus 1. And while we are using the while condition, if b is less than or equal to e, then m is equal to int of b plus e by 2. We have to find the beginning and end value. Why? When we have to use this, if your beginning value is less than or equal to end value, then you can go for midpoint. If element is equal to a of m, after finding the midpoint value, you can compare the element value with midpoint value. Then location is equal to m. You will get the location and go to step 4. Or else, if this condition is not true, you can go for if statement, that is LE is less than a of m, then end is equal to, we have to reset the value, end is equal to m minus 1, or else b is equal to m plus 1. End of, we will come for the end of while loop. And step 3, if location is greater than or equal to 0, then found in location, in which location we got the element, it will print the element called found in location, that is LOC, or else print element search is unsuccessful. If your element is not search, means it will print search is unsuccessful and exit. So this is your algorithm for binary search. First you have to use the methods, you have to set the elements, and we have to find the midpoint value. Using midpoint value, easily we can find the element, particular element in a sorted array. Clear? This is called binary search. Binary search means elements are in sorted list. How to find the particular location of the element in a given array. So today we learned searching operation on one-dimensional array. We have two methods called linear search and binary search. Linear search means searching a particular item in a given array. Binary search means when the elements are in sorted order, how to find the particular location or position of the array. And today's last topic is difference between linear search and binary search. Linear search means it can be used in sorted or unsorted array, but binary search is used only in sorted array. If the elements are already in sorted list, we can use the method called binary search. If the elements are not in sorted order, we can use the linear search. And array elements are accessed sequentially, one by one, from the beginning to till end. We can search the elements in linear search. That means searching is sequential in linear search. But in binary search, one must have direct access to middle element in the sub list. So using midpoint element, so directly we can go for the searching element. And access is very slow, but in binary search access is faster. And this can be used in single and multi-dimensional array. This linear search we can use in multi-dimensional array or single dimensional array. But this binary search used only in single dimensional array. We can't use this binary search in multi-dimensional array. And this technique is easy and simple in implementing. So linear search is very simple to implement, but the binary search is complex in operation. This binary search operation is very complex compared to linear search. In linear search, access each element in sequential order. So this is very easy to implement, but binary search operation is very complex compared to linear search. So these are the difference between linear search and binary search. So in my next session, I will come with a new topic called sorting an array. Thank you.